Hello, good evening, everyone. Good evening. So, first, just confirm in the chat the audio, video, and the screen sharing is everything fine for everyone? Okay, okay, Ramya, okay, Ayush, okay, Ishika, okay, done. So, now if I talk about the CAT examination and the allied examination like ZET, IFT, symbiosis, NAS, emoji, etc., various exams which are associated just like the CAT in India. So this topic, time, speed, and distance, is a very, very favorite topic as well as the important topic with the perspective of the examination. And we are having some different subtopics in this section, and you will find certain number of questions from this topic, time, speed, and distance, right? So we will be understanding some quick basic. I suppose by this time you people must have revised the basic fundamentals for all the topics and now preparing for the different level of questions. Okay. So I'll be just taking up a quick recap of the formulae of the concepts of this topic, and then we will be moving towards the questions, right? Okay. So just starting with this topic, time, speed, and distance. Yes. So as I have discussed with you, there are various subtopics: units of measures, proportionality, average speed, relative speed, objects crossing, boats in a stream, circular races, as well as the linear races, and escalator. Right. So these are the some different topics, subsections which are there related to time, speed, and distance. Right? Got it? Now, so moving with this part one by one. So in this topic, some basic introduction. So time and speed distance, as I have discussed earlier, is an important topic with the perspective of the all examination. And you will find certainly questions based on a time and speed distance concepts, right? Okay, now, so in this, we are having these three variables: time, speed, and distance. So first understand the relationship. First is, this is the first one. Speed is equal to distance upon time. This is the second one. Distance is equal to speed into time. And the third one, time is equal to distance upon speed, right? So these are the three different variations of a one same formula, right? Because we are having a three variable. So we can just rearrange these three variables, right? In three different manner. Okay. Now, so what's the relationship? Yes. Okay. So this is the first relationship. If two bodies move at a same speed, so this means I am having my speed constant, right? So distance covered is directly proportional to the time, right? So when the speed is constant, distance is directly proportional to the speed. So I can write here, speed is constant, right? So distance is directly proportional to what? Time. This is my first relation. Coming to the second one. If two speed move for the same time, so now we are having a time constant in this section, right? So now we are having my time is constant. So if I take my time constant, then so what is this? Distance is what? Directly proportional to what? Speed. So distance is directly proportional to speed. This is my second relation. And now come to this third relation when what? Distance is constant. So in this case, my distance is constant. So this time, if distance is constant, right? So this is time is what? Inversely proportional to which one? Speed, right? So these are the three basic expressions. These are the three basic proportionality in the time, speed, and distance. And with these three proportionality, we can solve all different varieties of questions which are based on time, speed, and distance, right? Okay. Now, when we are having a three different variables, so we are having a units for all these three variables. So for the time, we are measuring it in seconds, minutes, hours. The distance is normally measured in meter, kilometer, miles, feet, etc. And speed is measured in meter per second or kilometer per hour. Right? So if we are having a different unit, so the next thing is what? The unit conversion, right? How to convert a one type of unit in the other type of unit, right? So these are the different conversions of one unit to the other. But out of all these conversions, this the first one and this the second one are two very, very important. 1 kilometer per hour is what? 5 by 18 meter per second. And 1 meter per second is what? 18 by 5 kilometer per hour. Right? So these two are the very important conversion when we are talking about it, time, speed, and distance. Right? Okay. So there are some key rules for this, right, based on the proportionality. So what are the key rules? Yes, understand this little bit carefully. If two objects have their speed in a ratio A is to B, right? So now we are saying speeds are in a ratio A is to B. So I can say this is object 1 and this is the object, right? And we are talking about speed. And speed is A is to B. Right? Distance covered by the two objects is same. So in this case, what we are saying, distance is constant, right? So we have seen when distance is constant, speed is what? Inversely proportional to time. So if the ratio of speed of two objects is A is to B, I can say what ratio of time is B is to B, right? And this is a very important concept and we can solve almost all type of questions based on time, speed and distance, right? Okay. Now, so proportionality. Yes. So the first example. So now we are applying these concepts, these theorems into the question. So this is the first one, right? And what is this? When distance is constant. So if the distance is constant, what is there? Is speed into time, right? We know this. So this is the one example. If I change my speed 4 by 5 of the normal speed, then I reach 15 minutes late to my office. What is the normal time taken by me from home to office? Right? So very simple, very easy, but I have to master the logic, the concept here, right? So anyone quickly can type in your answer in the chat box. Okay. Okay, Arun. Okay. Okay, Raghav. So there are two persons, Raghav and Arun. They have typed in their answer. Yes, yes, Raghav, I got your answer. I got your answer, and we will just discuss. See, basically, the getting an answer is not very important right now, right? Understanding the logic, understanding the concept is more important. So even Ramya is also saying 60 minutes. Okay. Anushka, yes, Anushka is also saying 60 minutes. Okay, so let's solve. Now, we know distance is same, so speed into time, right? When distance is constant, we have just seen that what? Some different logic, right? So ratio of speed is A is to B. What is the ratio of time? B is to A. That is in the inverse proportional. Done. So this says distance, right? Distance is speed into time. Done. If I travel with a s kilometer per hour and I take t hours, I will cover a d distance. Right? Now, because of some reason, I am traveling with a speed of 4 by 5 of s. Right? So, time in a inverse proportion. So, I can say what? My time is 5 by 4 of t. Right? Distance is constant. So, this should be equal to what? D. Right? Earlier, the time is t. Now the time is 5 by 4 of t. So I can say this is 5 by 4 of t minus the earlier normal time t should be equal to how much? 15 minutes. The time by which I am reaching late. Right? So this is coming out to be 1 by 4 of t should be equal to 15, and my time is coming out to be 15 into 4, that is 60 minutes. Right? Got it? So this is a one way of getting the answer, right? This is the first method of getting the answer. Second, alternatively, I know distance is equal to s into t. Right? Now, what is my speed? 4 by 5 of s. Running with this speed, I am reaching 15 minutes late. Means I am taking 15 minutes extra from the normal time t. So if I multiply this with what? T plus 15. Right? Speed into time is what? D. Left part is same, that is D. You can equate the right parts. So this is St is equal to 4 by 5 of S multiply what? This is T plus 50. Simplify. S and S cancel. Cross multiply. So this is 5T is equal to what? 4T plus 60. No? And simply T is equal to what? 60 minutes. Right? I suppose you got this logic. Okay. So Gunjan is saying, why did we write the 5 by 4 of t? Okay, Gunjan. So see, Gunjan, we are saying speed is what? 4 by 5 of s. And time is in inverse proportion, right? So if I write this in an inverse proportion, so see this. If my speed is initial s is becoming 4 by 5 of s. Done. So my time, which is initial t, is what? That is in a inverse proportion of speed. So this is 1 upon what? 4 by 5 of speed. And this is in terms of time. So when you simplify this, this is coming out to be 5 by 4 of t. Right? Got it, Gunjan? Because when distance is constant, speed is inversely proportional to time. None? I suppose now this is clear to you. Okay. So first method, second method, right? Now coming to the third method. Right? So basically we are learning a approach, different logics, right? Okay. So distance is constant. When distance is constant, speed is inversely proportional to time. Done. So I can say this is my original speed, right? Original values, and these are my new values. Right? So if I talk about first speed, right? This is if I change my speed 4 by 5. So original speed is 1, right? So new speed is what? 4 by 5, right? This is the ratio. So can I say my ratio of speed is 5 is to 4? Done? Right? If the ratio is 5 is to 4 and I know distance is constant, so ratio of speed is inversely proportional to time. So what is the ratio of time? This is 4 is to 5. In the inverse proportion, we have just done no? If ratio of speed is A is to B, ratio of time is B is to A. Done. So original time is 4 unit, new time is 5 unit. Done. And I am reaching 15-minute late, right? 15-minute late. So this gap of 1 unit, right? This gap of 1 unit is equal to how much? 15 minutes, right? I want to know what? Original time, normal time. Normal time is what? This part, that is 4 part. Done. So if this is a 4 part, so one part is 15 minutes. So I can calculate 4 part is what? 4 into 15. That is what? 60 minutes. And this is what my normal time, right? So these are the three different methods by which I can identify the inverse proportionality. And this is a one part which always create a little bit trouble for you when you're solving the question, right? So if I understand this clearly, the different approaches, then it will be much easier for me to get the result, to get the answer, and to apply this concept, the proportionality, the ratio, right? I suppose. So you can just raise your hand if you have some query. Otherwise, you can just give a thumbs up here if you are able to understand. Right? Done? Can we move further? Okay. Okay, Sahil. 5t in the second one. Okay. So Sahil, this is cross multiplied, right? I just show you. So this S and this S is cancelled, right, Sahil? And we are multiplying these two equations crosswise. So t into 5 is 5t, and 4 multiplied this bracket t plus 15, so 4t plus 60. Right, Sahil? Okay. Okay, got it. So now moving with us is some more concepts, right? So I'm not taking this part, right? For the same constants, this one. Yes. So now just everyone try this one. The concept which we have just discussed. A train covers 50 kilometers and meets with an accident and moves at 4 by 5 of its original speed. Okay. And reaches its destination 45 minutes late. Then, had the accident occurred 20 kilometers further on, the train would have arrived 12 minutes sooner. Find normal speed, normal time, and distance between source and destination. Yes, everyone quickly, just give me some clues, some answer here. And this can be easily solved with the logic what I have just discussed. Okay, I'm starting and discussing this, right? So just pay attention here over the screen. Now, in the time and distance, it is always suggested first draw the diagram so that you can visualize the things, what is all happening, right? So draw the diagram clearly. So this says a train is moving and there is some source and some destination, right? So taking an example, this is my track. Then this is my source and this is my destination. Yeah? And there is some distance between source and destination. Now this says a train covers 50 kilometers. So starting from a source, train is till this point, and this length is how much? 50 kilometers. Okay? This is normal. Normal speed, normal time, everything is normal. And I mentioned this as the point A. Right? At a A point, the train is meeting with an accident and moving with a speed of what? 4 by 5 of the original speed. Done? We know if distance is constant, speed is inversely proportional to the time, right? So if speed is becoming 4 by 5 of s, done? So time is becoming what? 5 by 4 of t, done? Inverse proportion. Okay. So if accident is there, train is going slow, so there will be some extra time, right? So what is the extra time here? So extra time is present normal time 5 by 4 of t minus the normal time t, which is coming out to be 1 by 4 of t, right? 1 by 4 of t. Done. So this is the basic fundamental which I can relate from the previous example, right? And now my question is solved. Yes, question is solved. Okay. So train is starting from a S source, covered a 50 kilometer, and meet with an extent at a point A, reaching a destination with a 4 by 5 of the original speed and running at 45-minute late, right? So train is taking some extra time. How much extra? 1 by 4 of t, right? So can I calculate this? Yes, what? Normal time, right? What? Normal time. So how to calculate? So train is taking how much extra time? 1 by 4 of t, right? And this should be equal to how much? 45. Done, because this is the late time, right? So what is the normal time? T is equal to 45 into 4, which is coming out to be 180 minute, right? 180 minute is nothing but 3 hours, right? Easy. Yeah? Had the extent occurred 20 kilometers further on. So presently the extent is at a point A. Now the extent is suppose a point here, which is B. And this distance is how much? 20 kilometers. Right. Now read this carefully. The train would have arrived. Yes, what? Train would have arrived 12 minutes sooner. So what does this mean? Train is running is still late, right? Train is running is still late because the extent is now 20 kilometers further on. So train has covered a some time, right? Because 20 kilometers is run at normal speed, right? But still the train is late. How much late? This is, yes, how much late? This is coming 12 minutes sooner. From what? Earlier late time, which is 45, right? Earlier late time is 45. So now the train is running late how much? 33 minutes, right? So calculate the time. So this time is for what? Normal time is for AD, right? Now calculate the other normal time. So this is normal time. And now we are calculating normal time for BD, right? Normal time for BD. Yes, Vijay, yes, Abhishek, yes, this is now 33 minutes late. So extra time remains the same. 1 by 4 of t is equal to how much? 33 minutes, right? So now what's the normal time for BD distance? 33 into 4. Yes, 33 into 4. Quickly, tell me. 33 into 4. This is 132 minutes, right? 132 minutes. So with the difference of these two, I can calculate what? Normal time of what? AB, right? Normal time of AB. And normal time of AB is coming out to be 180 minute minus 132 minute, which is nothing but 48 minutes. Done. So first answer, normal time, right? 48 minutes. Done. So cover to what? Entire distance, right? So we will calculate the normal time. But if I calculate the normal time for this AB distance, so this is coming out to be 48 minutes, right? Okay. So now start calculating. Speed. So what is the speed? Distance upon time. Done. So I know AB distance, how much? 20 kilometer. What is the normal time here? 48 minutes. Minutes. And this is kilometer. So convert this into hour multiplied with 60. Done. So tell me, how much is this coming out to be? Yes, Ayush. So if the accident is not at a point A, now the accident is at a point B. Done. So train is running more 20 kilometer with a normal, right? Normal, nothing is up. So some distance is covered at a normal speed, right? So now train is covering some time. So train is reaching 12 minutes sooner from what? Earlier late time, that is 45, right? Yes, yes. Yes, Ramya, yes, Raghav. So this is coming out to be what? 25 kilometer per hour. So this is the normal speed. So what is the normal speed of the train? That is 25 kilometer per hour, right? Yes, Ishika, Raghav, Ramya, Abhishek. Okay, so this is 25 kilometer per hour. Now calculate the distance. Okay, so see, uh, this distance, this much is how much? 50. Normal distance, initial, there is nothing, right? Nothing happened. Now I know from a AD distance, what is the normal time? 3 hours. Done? To cover a AD distance. What is the speed of the train? Normal speed, 25 kilometer per hour. So this distance is how much? 25 into 3, which is nothing but 75 kilometer, right? This one. And this is 50 kilometer. So total distance 50 plus 75. So this total distance is how much? Yes, how much? 125 kilometer. Right? This is my total distance. Done. So distance between source and destination is coming out to be how much? 125 kilometer. Done. Now, if you want to calculate time, so time is what? Distance upon speed, right? So what is the distance? 125 kilometer. And what is the speed? 25 kilometer per hour. So this is what? 5 hours. So my normal time for this is what? That is 5 hours. Right? So okay, distance, right, Gunjan? Distance. So see, Gunjan, from source to point A, nothing is happening, right? Because this is normal running 50 kilometer. Okay. Now from A to D, we have just calculated, see this. This is A to D, normal time. And what is the normal time? This, 3 hours. Done. And we have already calculated the speed, 25 kilometer per hour. So from A to D, normal speed is 25, normal time is 3 hours, right? So my total distance is what? 25 into 3, 75, which is AD. And if I want to calculate the entire source and destination, so AD is 75 and source and A is 50. So 50 plus 75, 125 kilometer, right? Got it? You can take a screenshot of this question and with the complete explanation, right? So that you can understand the application of the proportionality. Yeah, can we move further? I suppose you people must have taken a screenshot for this. Okay, okay. So moving further, done. Okay, Ramya, okay, Khushbu, okay, Shika, okay, okay, okay. So some more application for this, right? So suppose this is a sum distance AB, right? This is some distance AB, and this is how much? 140 kilometer. Okay. There is a some person A standing at a A point, and this is running with a speed of 20 kilometer per hour. This direction, then towards the B. And there is a some person standing here at B, and this is running at a 15 kilometer per hour. And this is running towards A. Okay. So A is running with a speed of 20 kilometer per hour, B is running with a speed of 15 kilometer per hour, and both are running towards each other. Right? Both are running each other. Tell me, tell me, after how much time both will meet? After how much time both will meet? Okay, okay, Raghav. Yes, simple, right? Because I need to calculate time, and time is what? Distance upon speed, right? What is the distance? 140. A is running towards B, B is running towards A, both are running in the opposite direction. So what to do? We will add the speeds, right? So this is 20 plus 15, which is 35. And when I simplify, so my time is coming out to be 4 hours. Right? Very simple, very easy, right? Nothing to do with this. Then okay. Now, now listen here. What is happening? So A is going towards B, B is going towards A. Right? They are meeting somewhere here in between. Right here. So A is here, B is here, right? Somewhere in between. Now, after the first meeting, they are not stopping, right? They are not stopping. A continues moving towards B and B continues moving towards A. Okay, then when A is reaching here, right, immediately turn back. Okay, immediately turn back. And when B is reaching here, right, B is also immediately turn back. Then and now when they are turning back, they are meeting again here at this some point A and B. Right? Tell me, So this is what? Time of first meeting, right? Tell me time of second meeting. How much is the time required for the second meeting? Okay, Raghav, okay. But Raghav, please check. This is not correct. This is not correct. Yes, Anushka. Yes, is correct. Uh, okay, Raghav. Okay, so you're talking about after the first meeting. Okay, done. Then this is correct. Yes, yes, yes. From the start, this is correct. Right? So what to do? Now see this. Time to is what? Again, the same thing. Distance upon speed. Done. So what is the distance when they are meeting for the second time? See, 140 is the distance covered by A from A to B, right? Plus 140 is the distance covered by B from B to A. Plus when they are turning back, they both have covered how much? 1, right? So this is the total distance. 140 is 3 times, but the speed remains the same, which is what? 25 plus 15. And when I simplify, so time 2 is coming out to be what? 12 hours, right? Yes or no? Yes, yes, correct, correct. Right? So if I generalize this, right, this is a time 2. So for this distance, done. So distance 1 is what? If I take the entire distance is something d kilometer, right? So distance 1 is how much? D. If I say second meeting, distance is what? 3D. If I say the third meeting, distance is what? 5D. If I say the fourth meeting, distance is what? 70. And this will go on, right? Okay, Gunjan, I'll just tell you, right? I'll just tell you, not to worry. Uh, I first explained this, right? Okay. See this. This is my total length, right? This is 140 kilometers. Right? So first is running A. Okay. So A is running. So A is running and A is covering this much distance. Right? A is here. Okay. Then second, how much is this? 140. Then from A, 1 point to other point. Okay. Next, B is there, right? So B, yes. So if B is there, so B is covering this distance, right? So this is again how much? 140. Right? And they immediately turn back. B is going this direction, right? And A is again turning back from this point and going this direction. And they are meeting somewhere here, right? So together they are covering how much? 140. So 140, 140, 140, which is 3 times. Right, Gunjan? Yes, Ayush, this is correct. So I'll be just calculating the time also. Okay. So after the first meeting, this is 8 hours, and from the beginning, this is 12 hours for the second meeting, right? So I suppose you got the logic for this. Please confirm. Okay, right. So I'm just erasing this part here. Done. So this is what distance. First meeting distance is D, second meeting distance is 3D, third meeting distance is 5D, fourth meeting distance is 7D, and so on. Now come to the time. So we are saying with this example, like first I'll take the example. So first meeting time is how much? 4 hours. Second meeting we have calculated time is 12 hours. So we are calculating time from the beginning, is starting, right? So can you tell me what is the time for the third meeting? Time for the third meeting. How much is the time for the third meeting? From the beginning. No, Raghav, no, not 5T. Okay, you're talking about 5T, yes. T, I suppose you're taking the initial time? Yes, yes, yes. Yeah. So this is 20 hours, right? Yes, Anand, yes, Ishika, Anushka, yes, yes, correct. Khushbu, yes, 20 hours. For the next fourth meeting, this is 28 hours, right? And so on. Done. So, what to do? If I take the initial time as T, done. So, this is what? One distance, one T. So, this is 1 into 4. Right? Initial time is T, right? Then second meeting, 3 distance, 3T. That is 3 into 4. Right? Third meeting, 5D distance. This is what? 5T. 5 into 4. Right? Next, fourth meeting. So what is the time? 7D distance. So this is 7 into 4. And so on. So if I want to calculate the fifth meeting, right? So this is 9D. So what is the time for this? This is 9 into 4, which is nothing but 36, right? Yes, Rajvi, yes, Gunjan, yes, Khushbu, yes, correct, right? So I suppose that you are aware of with the normal distance and normal time when the persons are running on a straight line track and they run infinitely turning back every time, right? So when the race is started, so they are running, reaching opposite end, turning back, again opposite end, turning back, and this is going infinite. Yes, got it? Okay. So quickly, just tell me a one question. Yes, so this is a kind of relative speed, so we will be doing here only, right? Okay. So tell me. This is a distance AB, right? And this is some D kilometer. Okay. Right. So this distance is some D kilometer. A is a runner, B is a runner. So A is starting at 6 a.m. Right, going this direction towards the B and reaching here at 12 noon. Right? B is a runner starting at 6 a.m. and going this direction and reaching here at 11 a.m. Right? So A is going towards B and B is going towards A. Okay. Question is at what time A and B will meet. At what time A and B will meet. Yes. At what time A and B will meet. Uh, okay, Raghav, okay, okay. Okay, so let's discuss. So A is going this direction, right? Starting from 6 a.m., reaching 12 noon, taking a total how much? 6 hours. B is going this direction, starting from 6 a.m., reaching this point at 11 a.m., so taking a total 5 hours. Right? Okay, so now what to do? I am taking the what? Yes. Okay. So I'll tell you two ways, right? Okay. First is a normal and second is a shortcut. Done. So speed of A, distance divided by time. So this is what D divided by speed of B. This is what D divided by 5. Done. Okay. So we are having both the speeds. Now I need to calculate what? Meeting time. And meeting time is what? Distance divided by what? Relative speed. Done. So distance is what? D. And this is D by 6. This is D by 5. Both are running opposite direction, right? So this will be added. Simplify this. So this is coming out to be how much? This is 2 8 by 11 hours. Right? When you convert this, so this is 2 hours, and 8 by 11 into minutes is what? Multiplied with 60, right? Multiplied with 60. So this is what? That is 480 divided by 11. And this is approximately 43. Right? So they are meeting what? After 6 a.m. So after 6 a.m. meeting at, guess what? 8:43 a.m. Right? So this is what matters. Right? So they are meeting at 8:43 a.m. Yes, Anand. Yes, yes, sir. Correct. No? Now come to the shortcut. What to do? A is taking 6 hours, B is taking 5 hours. So what to do? LCM. LCM of 6 and 5, which is nothing but 30. So this I'll take a kilometer. So this is my D, 30 kilometer. Then I need to calculate time. So this is 30 divided by what? Speed of A is what? 5, and speed of B is 6. So this is 6 plus 5, right? So 30 by 11 hours. So when you simplify 30 by 11 hours, this is again nothing but 2 8 by 11 hours. Got it? Right? So you can take the screenshot of this also, because this is again a very conceptual question, the very important concept when the persons are running, right? And with this, I can calculate the second meeting, third meeting, distance and time, as we have discussed in the previous example. So now I know the distance, I know the first meeting time, so everything can be easily calculated. Right? So I suppose this is helpful for you to build up the concept of time and speed and distance. And we will be conducting such sessions in the near future also, so that you can just work over your faster speed as well as your conceptual clarity, and you can speed up your question solving, right? Yes, yes, Anushka, when we are taking the LCM, so this is coming out to be what? Distance, right? So we can take this LCM number as a distance. Done? Okay. So with this, we are winding up the session for this today. So Ayush, this is 2 hours now. So after the 6 a.m., this is 2 hours, 8 a.m. Right? And 8 by 11, the fractional hour. So 8 by 11, I am converting into the minutes because this is not complete hour, right? Okay, so we will continue with these concepts of time and distance in the near classes, right? In the subsequent classes, and we will understand and discuss other concepts, linear races, circular races, etc. Also, right? Okay, done. So with this, we are winding up the session for today. Thank you. Take care. Take care. Good night, everyone. Good night. Good night.